When we started the chapter real numbers, I have told that there are two very important properties of positive integers. So one was Euclid's division algorithm that we have already discussed. The second one is the fundamental theorem of arithmetic. In order to study fundamental theorem of arithmetic, we can consider a composite number 42. We can factorize this 2, 21, 3, 7. So 42 can be written as 2 into 3 into 7. Now you can see that we have factorized the composite number 42 and we got the prime factors. Which are the prime factors here? 2, 3 and 7. Can we find one more prime factor in this? No, it's not possible because 42 is having the prime factors 2, 3 and 7 only. That means that the prime factorization of 42 is unique, or the prime factorization of a composite number is unique, and we can write this factors 2, 3 and 7 in whichever order we want. For example, this 2, 3, 7 can also be written as 3 into 2 into 7, or 7 into 2 into 3, or 7 into 3 into 2, like that. So we can say that every composite number can be expressed as what? Yes, can be expressed as the product of their prime factors, but the prime factorization is unique, but it can be written in any order. So together we get the fundamental theorem of arithmetic. So the fundamental theorem of arithmetic states that every composite number can be expressed as a product of primes, and this factorization is unique apart from the order in which the prime factors occur. So using this fundamental theorem of arithmetic, we can find the HCF, LCM, etc. So that is the application of fundamental theorem of arithmetic. So we can do one question. The question is, find the HCF and LCM of 6 and 20. So we can factorize 6. 6 is equal to 2 into 3. 2 raised to 1 into 3 raised to 1. 20 is 2 raised to 2 into 5. 2 square 4. 4 into 5, 20. Now we can find the HCF. So what is HCF? HCF is the product of the smallest power of each common prime factor in the numbers. Product of the smallest power of each common prime factor. So which is the common factors here? The common factor, the only common factor in this question is 2. And 2 we have two different powers, 2 raised to 1 and 2 raised to 2. We have to take the smallest power, that is 2 raised to 1. And since only one factor is there, that alone will be the HCF. If one more factor was there, then we have to multiply with that. So here our HCF is 2. Now the LCM. LCM is the product of the greatest power of each prime factor. So here how many factors are there? 3 factors, that is 2, 3 and 5. And we have to get the greatest power. So 2 and 2 square, the greatest power is 2 square. 3 alone is there, so 3, and 5 alone is there, 5. So that is equal to 4 into 3 into 5, and that is equal to 60. So 60 is our LCM. Now in this question we got HCF equals to LCM equals 60. Now there is a relationship connecting HCF, LCM and the two numbers. That is HCF into LCM equals the product of the numbers. HCF into LCM equals product of numbers. Now from this we can find HCF. HCF equals product divided by LCM, and LCM equals product by HCF. Now we can look at this question and see whether this is correct or not. HCF HCF was 2, LCM was 60. So HCF into LCM. HCF into LCM was 2 into 60, that is 120. Product of the numbers were 6 and 20. So what was the product? 6 into 20, that is also 120. So HCF into LCM is product of numbers. Next question. Check whether 6 raised to n can end with the digit 0 for any natural number n. So 6 raised to n. We have to see whether 6 raised to n is ending with the digit 0. Now when can we say that a number is ending with the digit 0? We can say that the number is ending with the digit 0 if it is a multiple of 10. Or we can say that if that number is having the factors 2 and 5. Now look at our question. Our question is 6 raised to n. When we factorize 6 raised to n, it becomes 2 into 3, the whole raised to n. You can see the factor 2 here, but what is missing? The number or the factor 5 is missing. So can this end with the digit 0? Never. It cannot end with the digit 0 because the factor 5 is missing. So if we give any value for n, we can surely say that it will never end with the digit 0. 6 raised to n cannot end with the digit 0 for any natural number n. Now consider another number 4 raised to n. What is 4 raised to n? 2 into 2 raised to n. There also we can see that the factor 5 is missing. So we can say that 4 raised to n also cannot end with the digit 0 for any natural number n. Next question. Given HCF of 306 and 657 equals 9, you have to find the LCM. So we have the relation. What was the relation? HCF into LCM. HCF into LCM equals the product of the numbers. So HCF we have 9. 9 into LCM equals the product of the numbers 306 into 657. From there what is LCM? LCM equals 306 into 657, the whole divided by 9. 9 and 306 we can cancel. It is 34 and 34 into 657 is 2233. So without finding the factors or without factorizing, we can find the LCM given the HCF and the two numbers. So that's all for today. Thank you.